Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Paul A. Tipler. Okay. As usual, we first come to its statement. Okay. A cosmic ray proton approaches Earth vertically at the equator, where the horizontal component of Earth's magnetic field is 3.5 into 10 raised to the power minus 5 Tesla. If the proton is moving at 3.0 into 10 raised to the power 6 meter per second, what is the ratio of the magnetic force to the gravitational force of the proton? Okay, we have to find out the ratio of the magnetic force to gravitational force. Problem not tricky, quite simple, just use of Wien's displacement law, black body radiation. No, just use of this is quite simple to our previous problem, but not no black body. It is actually magnetic force on a moving charged particle. This is the first snapshot regarding the solution of this problem, which will provide us a foundation regarding the solution of this problem. Okay. A cosmic ray proton approaches Earth vertically at the equator, where the horizontal component of Earth's magnetic field is 3.5 into 10 raised to the power minus 5 Tesla. If the proton is moving at 3.0 into 10 raised to the power 6 meter per second, what is the ratio of the magnetic force to the gravitational force on the proton? Okay. Ratio of the magnetic force, we will denote it by FB, and to gravitational force we will denote it by Fg, where G is gravitational and B for magnetic field. Okay. Yes, students, before solving this problem in a formal or regular manner, we will have to go through a few snapshots which will provide us a foundation regarding the understanding of this problem. Okay. Here 1, 2, 3, 4 and 5 snapshots have been used. Okay. And after these snapshots our problem will be quite simple. First snapshot is magnetic force on a moving charged particle, F equal to QV cross B. F vector is equal to QV vector cross B vector. According to Newton's second law of motion, we know that F is equal to ma. So according to this, it will become QVB equal to mv square over r, where v square over r is the centripetal acceleration. Okay, ma, here in place of a there is v square over r. Centripetal or radial acceleration, these two terms are alternatively used, centripetal or radial. Okay. Next snapshot is also similar, but taken from different book. Okay. Radius of a circular orbit in a magnetic field, R equal to mv over q mod into b. Okay, where r is the radius of a circular orbit in a magnetic field, m is the particle's mass, v is the particle's speed, and q mod or q magnitude or q absolute value is the magnetic field magnitude. B is the magnetic field, V is the particle speed. Okay, where q magnitude or q mod or q modulus value is the q is the particle's charge, B is the magnetic field magnitude, m is the particle's mass, v is the particle's speed. Okay, and r is the radius of a circular orbit in a magnetic field. Next snapshot is also repeats the similar philosophy. Okay, magnetic force on a moving charged particle F is equal to qv cross b, where q is the particle's charge, v is the particle's velocity, and b is the magnetic field. Next snapshot consists of a large number of physical constants. We will use that value which will be required in our problem. Okay, mm, we have taken this snapshot several times in our previous problems also. Okay, next just acceleration due to gravity. Okay, the constant acceleration of a freely falling body is called the acceleration due to gravity, and we denote its magnitude with the letter small g. We will frequently use the approximate value of g at or near the Earth's surface as small g equal to 9.80 meter per second square or 980 centimeter per second square, because in 1 meter there are 100 centimeters. Centi means 100th part. Alternatively or equivalently, this meter per second or centimeter per second will be equal to 32.2 feet per second square. Okay, approximate value near the Earth's surface. Now, dear students, in accordance with these snapshots, now our problem has become quite simple. Let Fb be the magnetic force and Fg be the gravitational force. Okay, because we have to find out the ratio of these two forces. Let Fb be the magnetic force and Fg be the gravitational force. Then Fb equal to Qub or Qvb. In some cases, no difference. Okay. And similarly, Fg is equal to m into g, but here m is mass of proton, so we may also write small p as a subscript of m. Okay. Here capital B is written as a subscript of capital F because B denotes magnetic field. This is magnetic force, that is why Fb, where B is written as a subscript of F. Similarly, capital G is written as a subscript of capital F, as capital G is gravitational force, and hence Fg is written as a G being as a subscript of capital G, and because mass is that of proton, so small p is written as a subscript of mass m. Okay, moreover G is the acceleration due to gravity. Okay, where where p is written as the subscript of m is the mass of the proton. Now because we have to find out the ratio of these two, so we will keep magnetic force in the numerator and gravitational force in the denominator. So Fb over Fg becomes equal to this over this. Okay, this is 1.6 into 10 raised to the power minus 19 coulomb. This is the electronic charge. This is sometimes denoted by small q, sometimes denoted by small e. That is to say elementary charge or charge on an electron or charge on a proton. Okay. Then 3.0 into 10 raised to the power 6 meter per second. This value is given in the statement. This is the speed. Okay, moreover, this 3.5 into 10 raised to the power 5 Tesla, this is also provided in the statement. Okay, so out of these three values, two have been provided in the statement and third has been taken from the table of physical constants. Now we come towards the denominator value, which is the gravitational force, and this is m into g. This is the mass of the proton. Okay, 1.67 into 10 raised to the power minus 27 kilogram, and this is the 9.8 meter per second value of g, acceleration due to gravity. Okay, next, just simplification, nothing else, just simplification, just simplification. Dear students, actually here we are taking ratio of two forces, magnetic force and gravitational force, and we know that force is measured in Newton. So Newton over Newton, it means this ratio will not have any unit, it will be just a number. It is quite obvious, but despite this we will, if we want to understand the problem in its true sense, then we must have some knowledge about the fact that the unit, dear students, we see that in the enumerators which units are used: coulomb, meter per second, Tesla, and in the denominator kilogram, meter per second square. Okay, so it means, as in the numerator and denominator there are two forces and unit of force is Newton, so force over force, no unit, just numerical value, number. But now we are trying to understand how all these different units terminate and convert into one. Okay, so first we see that after simplification, it becomes this number. Okay, 1.03 into 10 raised to the power 7. Okay, after simplifying we come to conclude that all these multiplying factors become equal to 1.03 into 10 raised to the power 9 coulomb, Tesla, second per kilogram, and this is equivalently equal to simply this number. This unit is not written along with this because all these four units convert into one unity. As I have already said that this is the ratio of two forces, and so whichever is the unit of FB is the same unit of FG. Okay, Newton over Newton, so this ratio will not have any unit, it will be just a number. But for our understanding we are going to decide how these four units convert into unity. Okay, no doubt it is quite a separate thing, we can ignore it because we know that we are dealing with the ratio of two forces and unit of force is the same in the numerator and same in the denominator, so both these units are cancelled and ratio comes only in number. But now we are going to find out how all these four units merge in each other and give a result one unity. Okay, so first we have written them as equal to just number and we have ignored all these four units. Now we see how it becomes equal to 1. Okay, so within the bracket we have written that because 3 dots. Okay, when this third dot is above the two parallel dots, then we say that therefore. Okay, then it is read as therefore. But when third dot is below the two parallel dots, then we read this as because or since. Okay, because we are arguing arguing that this is so and hence that is that. Okay, so because coulomb into Tesla into second over kilogram is equal to coulomb into kilogram into second over ampere into second square into kilogram. Now we see what is the difference between this first step and second step. Okay, in the first step coulomb, in the second step also coulomb. Okay, in the first step second, in the second step also second, no change. In the first step kilogram, in the second step also kilogram. Okay, so what we have done, we have just used Tesla. We have replaced Tesla by what? We have replaced Tesla by kilogram ampere second square. Okay, it means Tesla is equal to kilogram per ampere second square. In the next step, we see that here kilogram will be cancelled with kilogram and 1 second will be cancelled with second, and we will get coulomb over ampere second. So it is equal to this can be equal to unity only if coulomb is also equal to ampere second. So in the here we have, it means that coulomb is equal to ampere into second. That is why our result becomes unity. Okay, so here in order to prove this thing in equal to unity, we have used units of Tesla as kilogram per ampere second square. And then we have used coulomb as being equal to ampere into second, and hence all this value becomes equal to unity, and our ratio becomes equal to this 1.03 into 10 raised to the power 9. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.